Our objectives for today are: clarify. Blockchain is a very popular buzzword, which means that it is overused. Each and every product is now pretending to be based or using blockchain, which makes the market very unclear. The objective of this presentation is therefore to clarify what blockchain is really, what are the main characteristics of this technology, and where it makes most sense to use it. Blockchain and Bitcoin. Blockchain has originally been created through Bitcoin, but now those two technologies tend to follow separate paths. While Bitcoin develops as a more and more popular cryptocurrency, blockchain technology is expanding in supporting an increasing number of use cases. Smart contracts. Smart contracts are a recent extension of the blockchain technology and bring the ability to represent assets of any kind, like financial products, insurance, warranties, to name a few. Thanks to smart contracts, blockchain is now becoming the Internet of Value. The agenda for this presentation will be to first understand the characteristics of money and crypto money and spot the difference between the two. Then we will go through an overview of Bitcoin. This will be the end of our agenda for today. We will then, in a second part, restart the presentation with the main Bitcoin characteristics and then move to what is usually called blockchain V2 or smart contracts. In that section, we will present the requirements for a cryptocurrency. From the current role and function of a currency, we will understand the requirements for a cryptocurrency and from there extrapolate on the characteristics and technical architecture supporting a cryptocurrency. This is mostly independent from a cryptocurrency itself, like for example Bitcoin. So in the next section, we will focus mostly on blockchain, which is the Bitcoin supporting architecture. This architecture delivers services used by Bitcoin, but also by a number of other cryptocurrencies, and which can be used also for completely different purposes than currencies. As we'll see, blockchain is about exchanging transactions and not exchanging coins, which makes blockchain potential use much wider. The abstract capacities developed by Homo sapiens allowed the development of elaborated payment systems and in particular the abstract notion of value. The representation of the value of a good is the pillar of any payment system. The agreed value enables the transactions. This has been instrumental in creating the civilization we live in. Transactions allow specialization. You don't need to produce or care for everything. You can specialize in an area, produce more than you need, sell the excess, and buy the rest you need from others. This specialization has increased productivity and the development of the technologies that have ever accelerated since the Bronze Age. In that respect, money has been a key element in the development of our civilization. Money represents physically the virtual value of the goods. It gives a tangible sense of the worth. Money has a certain number of functions. Medium of exchange. Money is used to exchange goods and services. It brings efficiency in the exchange of goods, facilitating the agreement among the two parties, in comparison with barter, where the two parties have to agree to exchange the goods, avoiding the coincidence of wants problem. Measure of value. A standard numerical monetary unit of measurement of the market value of goods, services, and other transactions. Store of value. Money permits to store value over time and perform deferred payments. To perform its function, money has to have some important characteristics, which we have to understand in order to understand what a crypto money should be. To be able to present the worth, money had to have certain characteristics, in particular durability. Money has to retain the same shape, form and substance over an extended period of time so that it does not easily decompose, deteriorate, degrade. Durability is important for the medium of exchange and the store of value functions. In ancient times, it was related to precious metal. Now, durability is coming from the backing of states and institutions. Divisibility. Money has to be divided in small increments in order to ensure the exchange function with efficiency. Transportability. Money can be transported from a place to another so that exchanges can be performed anywhere. Non-counterfeits. The money should not be counterfeit easily. This is ensuring the function of store of value. If money is easily counterfeit, it will rapidly lose its value. Gold was the first to meet all those characteristics. It is scarce, therefore it keeps its value. It is pure, therefore it is impossible to counterfeit. It is durable and transportable. Gold is scarce, but the quantity is uncontrolled. What would happen if one of a sudden we find a tremendous quantity of gold? Transportation is easy but much less than paper money, which has been developing rapidly from the 17th century. This means that money and payments have been evolving all over the centuries to match with the new needs. In that respect, cryptocurrencies are a new step matching the new needs the digitalization is bringing. Everything goes smarter and smarter, but payments are still as they were before the digital revolution. This becomes a bottleneck for the new services like micropayments. It is always good to go back to the sources, and here in particular to the white paper published by Nakamoto, the Bitcoin inventor, back in 2008. He said, while the system works well enough for most transactions, it still suffers from the inherent weaknesses of the trust-based model. Completely non-reversible transactions are not really possible since financial institutions cannot avoid mediating disputes. Nakamoto was clearly targeting cheaper transaction fees through a more efficient system. Due to the robbery risk, people were looking for something safer than cash. Yes, money is transportable, but it can be also stolen. In the late 80s and the 90s, smart cards started to flourish. Even this did not create a new currency. It was the first move into the current crypto money space. In the Netherlands, in the 90s, the first attempt was made by DigiCash with a product called eCash. It got a lot of attention, but the company finally disappeared at the end of the 90s. Microsoft at that time offered to license the technology and incorporate it in Windows. The distribution model was also a big question, whether it should or not be used exclusively through banks. PayPal came next in the beginning of the 2000s, enabling exchange of money between individuals, in particular between eBay users. There were a number of other initiatives, but all based on a centralized model, and they failed because of lack of trust or because they attracted a lot of attention and were closed by the regulators. Eagle, for example. As said earlier, Nakamoto's first target was to improve payments efficiency. In his introduction, he explains that the existing systems used over Internet do not ensure non-repudiation. Bitcoins is not presented there as a new disruptive currency to take over the fiat currencies. This is why traditional payment systems implement some risk mitigation measures, among them a high fee in order to compensate the fraud cost. Ensuring non-repudiation means that transaction costs can be lowered, the transaction being more secure. A non-repudiation mechanism is mandatory for a digital asset which can be copied indefinitely. This is often referred as the double spending problem. The proposal made by Nakamoto is to build a system which is using cryptographic proof instead of trust. Although not mentioned in his white paper, his contribution is totally in line with the cypherpunk movement, which also advocates a strong right for privacy against states and powerful companies. These ideas have been summarized by Assange's maxim: privacy for the weak, transparency for the powerful. As we have seen earlier, money has different characteristics. We are now looking at how these characteristics have been implemented in a cryptocurrency like Bitcoin. Durability. The electronic coin should not be altered or destroyed. To ensure this, Bitcoin is using cryptography to make the coin inalterable and use distributed database to maximize robustness. A centralized approach would be less secure as it can be attacked more easily. In terms of store of value, Bitcoin has been created with an anti-inflationist mechanism. The amount of money in circulation is fixed to 21 million of Bitcoins. Therefore, the value is preserved and will not decrease by inflation. Divisibility. The Bitcoin platform explicitly offers mechanisms to group and divide transactions. This is what we call the unspent transaction mechanism. Transportability. Being electronic by nature, coins are transportable from one wallet to another. No counterfeits. This is the main problem for electronic currencies. By nature, a digital piece of information can be copied infinitely without alteration. This is the double spending problem, which is solved again by cryptography. Even though cryptocurrencies and currencies have very similar characteristics, there are some differences though. First one is trust without intermediary. The main purpose of Bitcoin is to allow direct transactions between Bitcoin owners. You don't need an intermediary or a central bank to transfer value between people. Speed. Bitcoin transactions are validated every 10 minutes. It can be even faster for other cryptocurrencies, and it's much faster than the current systems, which are mostly batch systems. Anonymity. All the transactions are anonymous, like cash transactions, by the way. People are invisible. Transactions are executed against Bitcoin addresses. There is no guaranteed means to find the physical person associated with a Bitcoin address. The transactions are public. Everyone can see all the transactions happening on the network. No inflation. For Bitcoin, there is no money creation possible. The number of Bitcoins in circulation has been fixed by design to 21 million. As no additional coins will be created, the value is stable and Bitcoin ensures the storage of value. Fees. Transaction fees are smaller than transactional payment system. A typical transaction fee for a low priority transaction is 0.1 millibitcoin, representing currently around 9 cents, regardless the number of bitcoins sent. Before we continue, let's have a short summary on what we have already seen. What are the main roles of money? Money is a medium of exchange. It is also a measure of value and a store of value. What are the main characteristics of money? Money is durable, divisible, transportable, and has no counterfeits. What are the main characteristics of a crypto money? Trust without intermediary, speed, anonymity, and low transaction fees. Now that we have reviewed the money function and characteristics, we have understood the requirements for a crypto money. Let's now see how this has been implemented in the most popular cryptocurrency, the Bitcoin. It is important to understand the components of a cryptocurrency like Bitcoin. The so-called Bitcoin is in fact made of two separate components. The cryptocurrency itself, which has some characteristics like the number of coins in circulation, how those coins are inserted in the system, somehow economical parameters which may differ from one coin to another, even if they rely on the same infrastructure. And then the second component is the underlying infrastructure. This is the basement of a cryptocurrency providing the basic services. Of course, the two are tightly connected as the infrastructure has been designed to support the currency. But we'll see later today that the infrastructure designed for the Bitcoin currency, named blockchain, can be used for other purposes than currencies. Blockchain is pretty much like any system made of two components, the network and the database. The network is used to communicate securely transactions among the different components, and the database is the place where all the transactions are safely recorded. This is the ledger itself, and one unique feature of this architecture is that ledger is open and shared upon transaction counterparts. As we have seen earlier, Bitcoin has to be durable. The coins cannot be lost because of a technical problem, and the system has to be always available to ensure its function of medium of exchange at all time. Furthermore, the prior experiences in the field of digital money have shown the difficulty of establishing trust for a centralized body. All those requirements are pushing for a distributed architecture. This means that Bitcoin protocol, meaning blockchain, does not run only on one server, but is a truly distributed protocol running on thousands of machines, synchronizing themselves and having each a full copy of the transaction database. The distribution allows resilience. If one node fails or even if multiple nodes fail, the data will still be accessible. Distribution also increases integrity. If some nodes are attacked or the database is corrupted on those nodes, the other nodes will still have the correct information. To be able to alter the database, the attacker needs to own 51% of the power of the Bitcoin network. This distribution also brings trust. As all the same machines operate the same software, which is open source and can be verified by anybody. The bigger the network is, the safer. Because all the nodes have the same information at any time, they can verify that an asset has not been spent twice. The nodes get notified as soon as a transaction is performed, avoiding this amount being spent another time. Non-repudiation is another key element of the blockchain architecture. As seen earlier, because previous payment systems were enabling transactions to be repudiated, fraud has been developing increasingly. The fraud cost has been compensated by the transaction fees. Where the payment protocol implements non-repudiation, the fraud cost is lower, enabling to lower transaction fees as well. The non-repudiation is implemented through asymmetrical cryptography, which guarantees that the wallet's owner is the one he's pretending to be. Because the database is distributed, as soon as a user is willing to execute a transaction, the amount of money stored in his wallet is verified in real time. All the so-called unspent transactions are checked against the new transaction amount. Each transaction is signed with the owner's private key, which ensures non-repudiation, as the only owner knows the private key. The blockchain architecture is at the same time public and anonymous. All the transactions are broadcasted and public, at least some of the relevant fields, whereas the owner remains crypted. Only the wallet address is public. The real owner of a wallet is not known, and the network only sees the wallet address and verifies the ownership of the signed transaction through the asymmetrical keys. The only way to possibly find evidences of who owns the wallet would be through the transaction executed between different wallets and trying to find the IP addresses that have been used. This is more a matter of investigation, and nothing can ensure that the owner could be revealed. As seen earlier, the blockchain infrastructure is real-time. There is no batch process executed during the night. Everything is executed on the flow. The only batch process is the transaction block validation. This occurs every 10 minutes and seals together a block of validated transaction. When a transaction is sealed in a block, it becomes increasingly difficult to revert this transaction due to the non-repudiation mechanisms. There are roughly 400,000 transaction blocks since the initialization of Bitcoin infrastructure. Each block is enabled to seal a maximum of 1 megabyte per block. The transaction size varies from 0.2K to 1 kilobyte, and we currently see an average of 2,000 transactions per block. The throughput is therefore very limited. Currently only 7 transactions per second, which is far too less to substitute the Bitcoin network to current network like Visa or MasterCard, which supports something like 50,000 transactions per second. The Bitcoin currency has been defined with a finite supply to mimic gold. To prolong the analogy, those taking care of sealing transactions are called miners, and they get a reward each time they seal a block, solving a mathematical problem. The reward they get varies over time. It is halved every 2010 blocks, circa every 4 years. This reduction has been defined in order to compensate the anticipated Bitcoin value increase. The introduction of new Bitcoins follow a predefined law. Those Bitcoins are introduced each time a miner has successfully sealed a transaction block. Alice wants to transfer half a Bitcoin to Bob. She will use the unspent transaction she has in her wallet to transfer the money. The 1 Bitcoin unspent transaction is used as an input transaction for sending the money to Bob. As the Bitcoin is divisible, the 1 Bitcoin transaction is going to be split in 2 outputs of half a Bitcoin. One will be transferred to Bob and the other one will remain in Alice's wallet. Please note that in this example, transaction fees are neglected. The way blockchain works is not that coins are exchanged among users, but rather that transaction outputs are reused as transaction inputs to create new transactions. Note that a wallet does not contain any transaction. A wallet contains only the key associated with the Bitcoin address. All the transactions are and stay in the blockchain. After the transaction, Bob has received the half a Bitcoin, which is for him an unspent transaction, and half a Bitcoin will remain in Alice's wallet. The user connects to the blockchain infrastructure using a wallet. Normally, the wallet has a password to authorize access to its content. When the user wants to execute a transaction, the wallet application sends to the blockchain node a transaction which has a source address and a destination address. The transaction, as seen earlier, uses unspent transactions as input and produces 1 or more output transactions. The signature of this transaction is encrypted with the wallet's private key to prove the ownership of this wallet. After being verified on the node where the wallet application is connected, the transaction is broadcasted to all nodes. 10 minutes later at most, the miners compute a new block, including a proof of work. The transaction is then fully validated. A wallet can be hosted by a service on internet. Many providers like blockchain.info provide this kind of service. Or you can also set up a node directly on the Bitcoin network. A simple PC is enough, even though it takes few days to synchronize the database. This is done only once, and you need around 50 GB of free disk space. To sell or buy Bitcoins, meaning converting Bitcoins into fiat currency, you may use an exchange where buyers and sellers transact together. Finally, some companies offer interfaces services to connect the Bitcoin ecosystem to the outside world. As we have seen earlier, Bitcoin is a fully... In summary, blockchain delivers an infrastructure which allows counterparts to transact without trusting each other and without a middleman. The cryptographic proof is replacing the trust. It also provides a means to solve the double spending problem, ensuring that transactions are not counterfeit. Last but not least, it is a truly distributed system which provides resilience and prevents the so-called honeypot. As seen earlier, Bitcoin is a real-time electronic platform. This means that money transfers are done in minutes instead of days. It does not support the legacy of payments, which were taking time because settlements were done manually or in batches. It also provides some kind of anonymity. No one can easily find who is behind a wallet. It also provides a shared ledger. All the transactions are visible for all participants, and there are no redundant information anymore. We will develop further this essential characteristic in the second part of this presentation. What are the main characteristics of a Bitcoin network? A Bitcoin network provides distribution, non-repudiation, anonymity, and is fast, at least compared to traditional payment networks. What are the main benefits of a blockchain network? A blockchain network is solving the double spending problem. It's enabling trust via crypto proof. It is resilient. It is fast. It is anonymous, and it is a shared ledger where all the participants can see the same transactions. Many thanks for your attention, and let's start now the Q&A session.